So I think we're good. So let me just start by. So today we will do the same thing. We will introduce the concept of decision tree, and then going through two examples, I think, similar of yesterday's agenda. So let me just set it up for the drawing parts. So decision tree. So decision tree actually is our last chapter. I think it's chapter 12 or chapter 11. So uncertainty, decision tree. Okay. Decision tree is a decision support tool for making decisions considering the probabilities of different cases. So in order to construct the decision tree, if you have watched the YouTube video, it needs two simple concepts. One is probability, and the other one is expected value. Okay. So can you guys see my screen, by the way?
Yeah, it's working well.
Okay, thanks. So for probability, this is a really simple concept, and the expected value is developed based on the probability. So let's just refresh your memory. So probability is basically the chance that a certain scenario may occur, right? So typical example is flip a coin, right? So each side will have 50% of the chance for heads and tail. So let's take a look at one simple example for that. This is the same example in the YouTube video, but I'm just going through it again. So let's say you have a box. So let's assume that there's only a small hole here. You can reach in and pick one piece of paper from this draw box. So inside of the box, there's 4 pieces of paper. So there's the first piece of paper has a number 1 written on it, and then there's 1, and then there's a 2, and then there's 3, right? So for each of the papers, if you pick one paper at a time, so if you pick one paper from the box, the chance, so the probability of getting to, right, the paper 2 is 1/4 of the chance. So that's 25% of the chance, right? So that's also equal to the probability which you're gonna get a piece of paper with a number 3 on it, right? And since we have 2 pieces of paper for 1 with a number 1, so the probability for the piece of paper for 1, that will be 50% of the chance, right? So all these probabilities, so if you add all the probabilities, probabilities together equals to 1, right? So paper 2 is 25%, paper 3 is 25% chance, and paper 1 is 50% of the chance. So that's, let's say this is we have a box 1, right? Box 1. Now if we have another box here, similar idea, we have let's say 2 pieces of paper inside. So 1 4, 1 5. So let's just say this box 2. Right, so now you're picking papers. Now you try to pick a paper from box 1. So pick a paper. Pick one from box 1, and pick another one from box 2, right? Box 2. By the way, the probability for picking to get the value of 4 equals to the probability of getting the paper 5 from box 2 equals to 50% if you just consider picking a paper from box 2. Now, if you pick a paper from box 1, pick a paper from box 2, the probability the probability of getting the value 1 from the first paper, from the first box, and get a piece of paper of 4 from box 2. So this probability, right, will be equal to basically 50% times 50%, right? So that's 1/4 of the chance. So these two, so pick one paper from each box is considered as independent, right? So this is the independent independent event. Independent event. Because the paper that you're picking from box 2 does not affect the results from picking any paper from box 1, right? So they're independent events. So for independent event, if you want to have 2 independent events happening at the same time, so the probability equals to the probability of the event 1 times the probability of the event 2, right? So that's a case here. So if we go back to box 2 example here. Now, so this is for independent events. So for mutually exclusive events. So for example, for box 2, so you pick a paper from box 2. When you do that, you either get 4 or you get 5, right? Yeah. Maybe box 2 is not a good example. Let's do box 1. So you pick up paper from box 1. Let's change this to 1. So let's say if you want to calculate the probability of getting either 2 or 3, right? And getting 2 or 3, they are mutually exclusive from each other. So if your paper that you're picking out from the big box 1 is equals to 2, then that prevents you from getting a value of 3, right? And vice versa. So getting 2 and 3 are considered in this case as mutually exclusive, right? So the probability for getting 2 or 3 will be basically equals to their probability adds together. So 50%. Okay, so just highlight what we just go through here. Probability for each individual event, and for independent events, right? For independent events, the probability is time the probability times each other, and for mutually exclusive events, their probability is by adding together, right? So those are the basics for probabilities. Okay. So now, first, let me just collecting some feedbacks. So is that clear? So far. Okay. Sounds good. Yeah, so if you have any questions, you can just type in here, and then I'll follow up with the answers. Now, so that's the first concept for probabilities, right? We need that for building our decision tree. So the second concept is expected value. So expected value is considered as the average value, right? The average value of the results. Right, the results. So let's just use the same example here for box 1 here. So let's say for box 1, instead of picking one paper just once, we pick a huge number of times, right? So every single time when we pick a paper, we'll record the value of that paper, and then we put the paper back. So let's say the first time, for example, right, the first time we pick one paper, we get the value 2, right? And then we put the paper back. And we pick for the second time, and then maybe let's say we get a 2 again, and then we put the paper back. And then we pick it for the third time. Let's say this time we get a 1, right? And we'll keep doing that for many times, right? A huge number of times. Now, what's the average value we're getting? So the average value we are getting after we perform as many picks as we can, right? So that is our expected value. So to calculate that, we need 2 things. We need the probability of each event, possible event, and also we need the outcomes. So the outcomes, let's say outcomes of each event. So the outcomes in this case for box 1, we have 3 cases. We have 1, we may get a value of 2, and we may get a value of 3, right? And the probability for these 3 is, so to get value 1, our probability is 50% of the chance, right? So for value 2, our probability is 25%. And then for getting 3 is also 25%, okay? So our expected value equals to the sum of I equals to 1 to n, so pi times xi, right? So taking this equation, so that will be 50% times 1 plus 25% times 2 and plus 25% times 3, right? So this is our expected value here for box 1. So this is for box 1. So what does it mean is, if we're keep picking the papers from the box and then put it back, and over a huge number of times, the average value we can get for that paper is expected as this value here, right? So that's our expected value. And we can do the same thing for, let's say, box 2, right? So box 2, we have 2 values, 4 and 5. So we would have 4 and 5, right? And each of them is 50% of the probability. So their expected value will equal to 50% times 4 plus 5, right? So in this case, that will be 9, so that would be 4.5, right? Value, expected value. So that's for box 2, right? As you can see here, it's not either 5 or 4 number, it's in between 4 and 5, but this actually represents the average value. So if you're taking, so this equals to, if you are picking from the box 2 for many times, right? And then this is a value, right? And then each time you get different values, right? And if you take all this value and get a mean value, that will be equal to this expected value. Okay. So I hope that's clear for these 2 concepts before we move into the examples. So let me just collect some feedbacks. Any feedback? Questions? Is that clear? Yeah, I didn't calculate, to be honest. So I don't know if you follow exactly this equation, if that's the value, that should be the value, 1.75. Yeah. Thanks for calculating for me. Yeah. Thanks for calculating for me. Okay. So now let's go through the examples. So today we'll go cover 2 examples. So let's go for the first example. So in the first example, so let's say example 1. Example 1. Okay. So for example 1, so let's say we're a small business owner, right? We try to invest in 2 different projects. So project 1 and project 2. And after we invest in this project, we just say we don't have too much experience about business in overall, so we are expecting the project to be either a successful one, or it could be a failure, right? And since we don't have too much experience, we assume that the chance for success and failure is 50% over 50%. So this is the situation right here. And for when we invest in project 1, project 2, of course we're going to generate different revenues, right? We're going to generate revenues. So by running the numbers, we have a case like this. This is a simple table here. So let's say this is P1, this is P2. So this is project 1, project 2. And we have 2 scenarios after we invest in either project, right? So these 2 projects are mutually exclusive. Mutually exclusive. Okay, so that's success and failure. And we know each of them is 50% of the chance, right, for success and failure. So if we invest in project 1 and if it turns out to be a success, we will have $100 of return. And if it's a failure, then we'll lose $30, right? For project 2, if we invest and if it's a success, then we gain $90. In the meanwhile, if it's a failure, we'll lose $10. So as you can see here, project 1 has higher risk, right? So if we success, we'll gain another extra $10. But if it's failure, we will lose another extra $20. So the idea is to use. So from here, we can use a decision tree model to analyze that decision tree model. So in the decision tree model, there are 3 components, right? 3 components. The first component is a rectangular box. This is called decision node. Decision node. Second type of node is called chance node. So chance node. Chance node. Okay. And then you have the lines represents the branches. Branches. So it's the 3 components. Actually, it's fairly simple. So, so for us to start with this project, we can start from the left to the right. The first node is always the decision node. So decision node, because we need to make a decision. Right? Eventually, the purpose of having the decision tree is to make a decision. So we have 2 branches, right? In this case, so we have project 1 and project 2. So we either choose project 1 or project 2, right? So that's why we consider 2 branches here. And then we have a chance node. So chance node and chance node. Chance node. The reason it's called chance node is because it's always connected to the probability branches, right? That's the first thing. Second thing, at the chance node, we always calculate in the expected value. I'll demonstrate that in a second. So if we invest in project 1, 2 scenarios. So the first scenario is success. So we're gonna have 50% of the chance that will give us $100. $100. And then if it's a failure, we'll lose $30, right? Same thing for the node 3, right? So 50% of chance is success, 50% of chance is failure. So that's going to be $90 and lost $10 here. Okay. So now for us, so if we choose project 1, what is the expected return? Expected return. If we go with project 1, right? That's basically asking what is the expected value here for node 2. So to calculate that, that's basically the expected value equals to the $100 times its probability, which is 50%, plus minus 30 times 50%, right? So this will give us a number here, 35. So that's 35 here, $35 here. Okay. So we do the same thing for, so what's the expected value? Expected value for if we choose project 2. So that's basically asking what's the expected value for the node 3, right? So for node 3, node 2. Node 3 will be $90 times 50% plus minus 10 times 50%. Okay, so this will give us $40. Okay, so now we have these two numbers here, 35 versus 40. Just by looking at these two numbers, it's very obvious we can go with project 2 because project 2 has a higher expected value. So higher expected value. Expected value. Right. So this basically, it's a simple question demonstrate the idea of decision tree. Before we go into the second problem, which is more complicated one, just want to ask a question here. So if we choose, so let's say if we choose, project 2, does that mean we always make profit? Yes or no? Right. From decision tree analysis, we know that project 2 is a better option because it generates a higher expected value. But the question is now, if as a business owner, if we choose to invest in project 2, does that option always make us a profit? Yes or no? Any thoughts? So if we choose P2, will it always make profit? So the answer is no, right? No, it wouldn't give 50% of losses, but your losses would become comparatively less than choosing project 1. Not necessarily, yes. But I think you guys get the concept. So this $40 here for expected value, that's just the expected value, right? So it's same as what we do for the boxes, right? Picking the drawers from the box, picking up the papers. It's an average number. If we are repeating repeating investing in project 2 over and over and over again, that's our expected return. So if we just choose project 2 and invest for once, we may end up with a situation where we're going to lose $10. So, but from a probabilities perspective, we choose project 2 over project 1 because it has higher chance for us to make a profit in this case. So that makes sense? Okay, so we can move to question number 2 here. Okay, let me just save this. So this is decision tree 1. So I can send it. Okay, so here's the notes. Okay, that should be good. So now let's take a look at question number 2. So question number 2 is an example where, say we have a company, need to make a decision whether to do a partnership with a Chinese company or not. So let's say we have a company, we have a North American company. So that's North American company, right? North American company. Just give me 1 second. Sometimes, okay, I need to probably redo this. So just copy this and close this. And so let me see if it, okay, so this time is good. So say we have a North American company. So North American company. We're looking if we are going to partner with a Chinese company. While we're partner with the Chinese company, there is another, we'll say, 2 scenarios that we're facing. The first scenario is if we partner with the Chinese companies, the North America market demand may increase, or it may decrease, right? The Asian market demand also may increase or decrease. So that's this column and this column here, okay? And we know that for both cases, for North American demand cases, for increase, there are 60% of chance, right? According to the historical data and forecasting, there is 60% of chance for increase of the demand. And then there's 0.4% of the chance for decreasing. For Asian market, there is 0.3%. There was 0.3. So 30% of the chance. 30% of the chance for increase. Right, and then so there is 0.7% of the chance for decreasing. And for each cases, we have the expected revenue generated, right here. The question is asking, so now use the decision tree to select the best option, okay? So I'm gonna pause here for maybe 2 to 3 minutes, so you guys can draw quickly a decision tree on your notes, and then we can come back and check your answer. So I'll pause for 2 to 3 minutes. Okay, so let's come back to these questions. Hopefully you had time to draw the tree on your notes. Again, we start from left to the right. So there's actually, if I want to see the decision tree model, it has 2 steps, right? So step 1 is left to the right. So this is for building the tree. So develop the tree. And then, did I unmute myself? Yeah, I think so. And then second step, after you have the tree, is to from the right to the left, right? For calculating the expected values. Now, at the very left, the first node we're gonna have is our decision node, right? So that's node 1. So from here, actually, we have 2 branches. As you can see, we have 2 scenarios here. So I'll be here and here, right? So this is this is a partnership, and this is no partnership. Okay, so that will lead to our second chance node and the third chance node here. And then from here, we'll have 2 branches. That's the second column here, to taking care of the second column here of the questions. So we'll have 2 cases here. One is a North America increase, right? Increase. And the second case is North America decrease, right? Decrease. So this will branch out to 2 different nodes. This node is 4. Let's say this node is 4. This node is 5, right? And we know that this is 0.6 of the chance. It's North America demand is going to increase, and there are 40% of the chance North America demand is going to decrease. Okay. So once we taking care of, so we do that same thing for the node 3 here, right? So North America increase 0.6. So that's our node 6 and node 7. And the North America decrease. Okay, so that's 0.4. So 40% of the chance. So here correspond to this. So from here to here. Okay. So now let's take a look at the third column. It's going to be here. We'll have 2 scenarios. One is the Asian market increase. So that's 30% of the chance. So that's a lead to our another situation here. Or we don't need a node here because that will lead to our revenue. So revenue is $2 million, right? And then our Asian decrease, that's 0.7%, so that's 70% of the chance, so that will be 0.75 million. And then we do the same thing for this node. So that's 0.7, 0.7, 0.3, 0.7, so that's going to be 0.5 minus 1, 0.7, 0.3, 0.7, so that's going to be 0.75, 0.5, and then same thing for this. So 0.3, 0.7, so that would be 0.1 million and 0.3 million, right? So this corresponds to this, and the revenue corresponded to this column here. Okay, so that's our first step from left to the right to develop the tree. So now we need to perform the second step, conduct the second step. So the second step is to calculate the expected value. So the expected value. So where we need to calculate the expected value, we need to calculate the expected value at the chance nodes. At the chance nodes. Right? So expected value of 4, 5, 6, 7, right? And from 4, 5, 6, 7, we will calculate 2 and 3, right? And then from 2 and 3, these two values will make a decision based on that. So if I drag this a little bit bigger, so for expected value 4, so that will be equal to $2 million times 0.3 plus 0.75 times 0.7, right? So this will give us 1.125. Okay, so if I'm just calculating using the same methods, I'll get value of here. So 1.125 minus 0.55 and 0.575 and 0.24. Okay, so now we know the value of here. So from this 4, we can calculate the expected value for 2 and 3. So for expected value, for example, for 2, right? So that will be equal to the value at node 4, which is 1.125 times the probability, which is 60% of the chance, plus minus 0.55, that's the expected value at node 5, and times 0.4% of the chance, right? So this will give us the value of 0.455. So we'll have the value here, 0.455. And then we do the same thing for node 3. So that will be 0.441. Okay. And then now, so expected 3 equals to 0.441. So based on these two values, we will choose project case, so partnership, right? Because it has higher value, partnership. Okay. So basically, we'll choose this branch here. Oh, yeah, this branch here. Okay. Okay, so that's how we solve these questions. Any questions? Any question or feedback? Going to save this for DT2. So DT2. Yeah, I think the decision tree is relatively straightforward as long as you understand the probability and how to use the probability for calculating expected values. And 2 steps. One is from left to the right, and then the second step is from the right to the left to calculate the expected value. And based on that, make decisions. I think it's quite straightforward. So these 2 questions hopefully give you a clear understanding about decision tree and how to calculate them. So in the coming week, I think we still have, so 1 more week and 1.5 week for this semester. So I think we need to cover a few things in the coming weeks. So here I think we need to cover the break-even analysis. And then we need to probably do some tutorials for assignment 3. And then we also need to do some sessions, I think, for the final exams. So for the final exam, speaking of the final exams, I was checking with my department. They were talking about doing everything just online, the way we're doing with the assignment. I think our final exam for this course is on the 24th. So that'll be 24. I think it's 24 of April. Yeah, 24th of April. So I'm still thinking about how we can do that. One possible way is to send the questions at the beginning of the time and have you guys finish that on time and then scan it or photocopy that and send it back to me through D2L or email. Do you guys have any thoughts on that? Final? Are you guys okay with is it possible just use the D2L quiz function? Yeah, that's possible. I can look into that and do the D2L quiz function. But that I can only do for single choices. My thinking is like we're gonna have some single choices, and then we have 2 or 3 questions for calculation. Time to scan the answers. Yeah, so when you guys submit the assignment, how you guys scan it? Like you guys have scanner at home or early this week, I think many ran out of time. The site froze when they tried to submit. Yeah, that was one of the things I heard from the department meeting was for the concrete exams. They tried to do it in D2L, but there was some technical issue. So I was thinking about, would you provide some sample question like the meeting? Yes, I would do that. Yeah. So I will provide sample questions. So I will provide sample questions and tutorials for finals. Yeah. So going back to Emily's comments here that for the concrete exam, from what I heard is there was some technical issue. So student was running out of the time, and there was a problem for the D2L quiz system, I think. I need to look a little bit closer into that option, but what I'm thinking is like maybe I can have the same questions in a PDF. So same question as a PDF. So that has the single choice of questions along with the 2 or 3 calculation questions, right? I'll send that PDF, let's say at 9 a.m. On that day or to start, right? I'll send it maybe like 8:45-ish a.m. And then you guys can take that and write everything, try to calculate everything on your paper, right, on your sheets. And I will stay online on the Teams. So if you have any questions, you can ask me the questions. I will be on Teams. And then so the exam will run from 9 a.m. to let's say 11:30. I think, yeah, roughly like 2 hours, 2.5 hours maybe. And then I will allow for another maybe 20 minutes for submissions after the exam time. So I think that could work. What do you guys think? So basically send the PDF of questions around 8:50, like 8:50. Then you guys do it, and then submit before 12. Yeah. I think it's 3 hours. Yeah, because the department was really concerned about people working together. But I think in this case it doesn't matter anymore, because if it's just for 3 hours, the time is relatively short. So even though you don't want to risk waiting for somebody else finishing the questions for you, so I think it should be okay. Okay, so let's go with that. I'll make the questions. Maybe I will just making a little bit more questions and randomize the questions in different PDF as I send out. Maybe I'll divide the class into 2 groups and send out 2 different PDFs to different groups. So in this way, you guys can have a little bit mix and match there. Okay. So thanks for attending today's session. I will post this video again for those of you who didn't have chance to watch this. And then next week I will host the other live sessions for break-even analysis and the tutorials for assignment number 3. Okay. So any more questions? Okay, so you guys have a good weekend, and see you guys next week.